In a separate video, we looked at different solutions to overfitting, and one of the primary ones is by validating the data set. So, two common ways of doing that are by split validation, where you divide the data set into two, and you use part of it to train the data, to train your models, and then the other part to test or validate the trained models. And then the other approach is cross validation, where you split the data set into multiple uh, sets, maybe typically 10, it could be more, it could be fewer, but where each partition takes its turn being a test set where the majority of the data is used to train, and then the smaller partitions used to test, and then they each take turns going around. So this brief video, I'll just talk about the advantages and disadvantages of cross-validation as a solution. So first, looking at the advantages, you have to understand that when split validation divides the data, so let's say you do even a 70-30% split, 70% of the data is used to train the data set, and the 30% that is used to test or validate the data is not used to train at all. And that means that if there are some unique features in that 30%, then it's never seen by the training data, and that is not incorporated in the training of the model. So no matter what the split is, there's always part of the data that is never used to train the model, which means that the model is developed not based on the full data set, but only a partial set. And if there's some interesting or unique important features or phenomena going on in the part that is reserved for testing, it never makes it into the model. However, cross-validation, by letting every single partition take its turn, eventually across the various training rounds, every bit of data in the data set is used for training. So all the information that is available is incorporated in the training. Another consideration, well, this has to do with one of the disadvantages, so probably the major disadvantage of cross-validation, and that is the fact that it is rather computer intensive because even with tenfold, it has to do the same thing 10 times instead of just once in the case of split validation. So being computer intensive, the fact that just tenfold, that's going 10 times, becomes a limit that produces fairly good results. And even if you go higher, 15, 20-fold, you're not adding much quality. Just tenfold is sufficient to attain high quality in this strategy of splitting up the data set many times. And so that is advantageous, that it's not necessary to go to 100-fold to get higher quality models. And another issue, kind of related to the first one, is that cross-validation captures greater variation in the data. And that's the fact that it carries out in tenfold cross-validation the analysis 10 times, and so it can find more unusual partitions. It might be a little bit more robust to outliers. If there's outliers in some partitions, and they won't show up as much when you go through them. If there's any unusual subset of the data, it's better detected because eventually it goes through various splits of the data and analyzes them in that way. Okay, that said, there are some disadvantages. I've already mentioned the fact that it is computer intensive, and so it runs the data set 10 times. So that means the procedure is going to take 10 times as long to run, and that's not just slower in time, but that's more power consumption. So more power consumption has cost implications. You have to pay for the electricity, but also it has environmental implications where it means that there's more energy being used to train one model 10 times as much in this case. Well, depending on how it's designed, but there's a lot more energy being used. Then another disadvantage, and this is perhaps a minor one, but it's somewhat more complex to interpret the results because the cross-validation doesn't have just one result for the entire data set. It produces those, and those are called micro-averages. But each validation set has its own averages, its own variations, its own performance measures, and then these need to be averaged across, and those are called macro averages for each cross validations. And this is normally what you want to look for. So this adds a bit of complexity because there's a lot more data there. You have to look at what is more appropriate to look at in what case. But though I consider that a relatively minor disadvantage that is more than outweighed by the advantages. And so cross-validation is really the state-of-the-art approach, even though there are variations to it, but it's the basic approach that is used much more than a split validation for professional data mining.